This video is on heating curves and phase diagrams. So we've talked already about states of matter, and we said that as we add energy to a state of matter, they're going to change from a solid to a liquid to a gas. When we add energy and they change from solid, liquid to gas, we said that they start to vibrate faster and they start to spread out. So depending on the type of energy, we can have kinetic energy. And kinetic energy is the energy of vibrations or of movement. And then we can have potential energy, and that is going to be the space between the molecules. So if we look at our heating curve, we're going to look at the heating curve of water to start with. And I have temperature on my y-axis and heat added on my x-axis. And sometimes these will have time on their x-axis, or they'll have heat. When we start out with zero or very little heat added, which means a low temperature, our state of matter is going to be a solid. Here, I'm increasing the vibrations of my solid. So my molecules are starting to vibrate more and more and more, so they're increasing in kinetic energy. Then you'll notice that our graph kind of hits this flat plateau area. This is where we have our phase change. Here, I'm going from a solid and I'm transitioning to my next one, which is a liquid. The phase change from solid to liquid, going from solid to liquid, is melting. On this line, we are said to have an equilibrium. So that means that I have both solid and liquid states happening at the same time. So this is an equilibrium. So as I increase in kinetic energy, my molecules start to move faster and faster and faster, and then I hit this phase change. So here on this phase change is where I'm going to increase my potential energy. My molecules are going to start spreading further and further apart, and as they spread further apart, they're going to transition from a solid to a liquid. Then I go ahead and I start increasing in temperature again. And as I increase in temperature again, I'm increasing in their kinetic energy, so their movement starts to increase as a liquid. So my liquid molecules get slipperier and slipperier and move faster and faster past each other. And then I hit my second phase change here. Here I'm going from a liquid to now a gas. And the phase change between a liquid and a gas is evaporation. So that means on this line here, I have both liquid and I have gas happening at the same time. So that's another equilibrium. During this time of my phase change, I'm increasing the potential energy of my molecules, so they're spreading further apart. After everything has been converted to gas, then my gas molecules start to move faster and faster, and my temperature increases again. And that means my kinetic energy increases. So we can say that kinetic energy and temperature are equal. When I have no change in temperature, I have change in kinetic energy. So temperature is a measure of the kinetic energy of a molecule. And kinetic energy is at Ke. The other type of graph that I can have is a phase diagram. So a phase diagram talks about our three different phases. I have solid, liquid, and gas. In my axes, I have pressure on the y-axis and temperature on my x-axis. We have these lines here that are our boundaries. So here is our line comes up. That's our boundary between solid and liquid. It's also our boundary between solid and gas. And then we split our liquid and gas, and that's where we have liquid on one and gas on the other. On these lines, we are at equilibrium. So I could read at this point that temperature and that pressure, and that would be a pressure and temperature where I have both solid and liquid happening at the same time. We can also cross our boundaries, so by lowering the temperature or increasing the temperature at a certain pressure, and that's going to change our state from solid to liquid or liquid to solid. And same thing here for liquid to gas. I can be at a certain temperature and decrease my pressure, and that's going to change my state of matter. We have a specific point on here, or two of them. The first one is right here, where all three of my lines come together. This is called the triple point. And here, all three states coexist. So they all happen at the same time. So at this temperature and pressure, I have solid, liquid, and gas happening at the same time. And we'll watch a YouTube video that shows us what this looks like. It's actually pretty neat. My other point is my one at the end of my gas-liquid equilibrium line. And this is called the critical point. After this point, there's no longer a distinction between a gas and a liquid. So we can't turn one back into the other. One other thing to look at is for every other thing besides water, our line between solid and liquid has a positive slope. It moves forward. Our line increases to the right here, kind of angles forward. For water, it has a negative slope and it angles backwards. And that has to do with the fact that solid water or ice, so this is because of our bonding in water, which causes ice to be less dense than our liquid, which is why ice floats. Okay, so we want to be able to read different points about this, these two graphs, and then be able to draw conclusions from them.